Hello students, welcome you all to the next session regarding discussion of refrigeration and air conditioning, a continued part. In the last session students, we have discussed regarding the working of vapor compression refrigeration. In today's session, we will be discussing the next type of refrigeration known as vapor absorption refrigeration. As already I have said students, if you have any queries, you can send me an email to the email IDs which are visible on your screen. As well as you can subscribe to my YouTube channel, leave the comments in the YouTube channel, or you can send me a message to my WhatsApp number also. Okay, students. Now let us begin today's session regarding discussion of vapor absorption refrigeration. So first of all, students, vapor absorption refrigerator, it is also similar to that of vapor compression refrigerator only. It is also similar to that of vapor compression refrigerator only. But here the method of raising the pressure, it is a little bit different when compared to the vapor compression refrigerator. Here the pressure is being raised with the help of absorption method. So that is the reason that here in this particular technique, we are raising the pressure with the help of absorption method. That is the reason we call it as a vapor absorption refrigerator. Here we don't have a compressor, but this compressor, it is replaced by the other devices, that is absorber, pump and a generator. So the function of compressor, it is done by the other three parts, that is absorber, pump and generator. Then as I said here, the vapor is being absorbed. For the formation of vapor, the heat source is used, and this heat source, it is developed by the combustion of fossil fuels you can use, or you can prefer the solar energy, or you can use any one of an electric heating element also, which means the vapors which they are absorbed with the help of combustion of fossil fuels. You can use a fossil fuels as an energy source, you can use solar energy as an energy source, or even the electric heating element. And when you are preferring, when we are using these devices, absorber, pump and generator, here this system, that is vapor absorption refrigerator, it is running smoothly. We don't have any moving parts like the compressor. So in the compressor, I said that we are having a piston and cylinder arrangement which reciprocates continuously. There are sliding parts. As a result, there is a lot of noise and disturbance developed. But here, as we don't have a compressor, the system works very much smoothly and quietly when compared to compression system. Now, moving ahead. Generally, in the vapor absorption refrigerator, along with the refrigerant, we are using a solution we call, which is responsible for the solubility of a refrigerant happens easily in water. So refrigerant gets easily soluble in water, and we call that a refrigerant solution as an absorbent, known as absorbent. So for vapor absorption refrigerators, we are using two types of combinations. The one combination you can see on the screen is initial combination. If you are using ammonia as a refrigerant, then water is an absorbent. This is the first combination. Second combination is if I use water as a refrigerant, students, then now the absorbent becomes lithium bromide. So in very simple words, along with the refrigerant, there is a need of an absorbent, and the absorbent function is both the refrigerant gets easily soluble in absorbent, and then this absorbent, it is taken to the heat generator where it is being raised to a higher pressure by boiling, by the formation of vapors, and then those vapors are separated. So for that purpose, along with the refrigerant, an absorbent is needed here. So now you can use any one of the combinations. So please remember always, students, if you are using water as a refrigerant, then the lithium bromide becomes absorbent in that particular case. If I am using ammonia as an refrigerant, then there water becomes an absorbent. Let us see the principle and working of the vapor absorption refrigerator. So as I said, it consists of the same devices when compared to the VCR, but only a compressor replaced by 3 other parts. But let us see those parts. It consists of an evaporator within which the heat is extracted, where the refrigerant gets evaporated, vaporizes to form the vapor phase. Then here we are having absorber, pump, heat exchanger, generator. Then we have a condenser and we have the expansion valve. So you know these three parts, that is evaporator, condenser, expansion valve, all were available in the VCR process. Here we are more interested to use other devices, that is absorber, pump and a generator. Let us see the sketch of this particular setup. So as I said, you can see here, this is the evaporator, absorber, then we have a pump, heat exchanger, we have generator, condenser, expansion valve. Then at the same time, if you observe everywhere, we have shown the different phase changes occurring as the refrigerant passes from all these devices. Before I go to the explanation of all these parts, let us discuss the importance of the additional parts which we have used here. That is, first one is the absorber. So as I said, students, let's discuss of the absorber. So as I said, students, here we are using the refrigerant as which one? Ammonia. So when we use ammonia as the refrigerant, so obviously the absorbent is going to be water. So in this absorber container, the water along with ammonia solution mixes together to form a strong ammonia solution. Water mixes with the ammonia vapors to form strong ammonia solution, and this strong ammonia solution, with the help of a pump, it is pumped to the generator, where by the pumping action itself the pressure is being raised, and this strong ammonia solution, it comes and is dumped in this generator. Now in this generator, the heat is being supplied to the heating coil, as I said, by the combustion of fossil fuels, solar energy or heating element. So when the heat is supplied to this solution, strong ammonia solution, which is present inside this container, the ammonia vapors, they get separated from the water, as the boiling points of ammonia and water are different, and these ammonia vapors, they get separated, the density is lesser, due to which they pass through this line and enter the condenser. Then the remaining weak solution, it is taken off back towards the absorber, passing through this device known as heat exchanger. So the purpose of using the heat exchanger, students, here is, as I said, initially when the strong solution, it is pumped through this network towards generator, it is strong ammonia solution, say it is warm in nature, but it is cold in nature, but the weak solution which is coming from this generator part towards the absorber, this green color network, it is warm in nature, it is having some temperature, say it is warm weak solution, it is warm weak solution. It is warm weak solution. So generally you know that always the heat flows from a hot body to cold body. So this warm weak solution, it is having some amount of heat within it, and the other side, the pump which is pumping the strong solution to the generator, its temperature is cold in nature. So here what happens here in the heat exchanger is, the students, the heat of this warm solution, it is being rejected, and this heat, it is absorbed by the strong solution which is passing through this network of the heat exchanger, which means by the time it reaches the stronger solution reaches the generator, it has become a little bit hot, its temperature is a little bit increased, which means for the next cycle, the amount of fuel supplied for heating the strong ammonia solution you can reduce. So you can say that it is a heat conservation process to some extent. Now let us begin with the working part, students. Initially, I'll start from this point. Initially, the low pressure, low temperature liquid ammonia, it enters into the evaporator, where in the evaporator it absorbs the heat from the food materials, gets vaporized and transfers to vapor phase, liquid to vapor phase. So when it comes out of the evaporator, if you observe here carefully, students, now it has come to the low pressure, low temperature ammonia vapor when it comes out of this evaporator. Please see the arrow directions from evaporator. It should pass towards the condenser. Okay. So now it is entering, and then if you observe here, this refrigerant, that is at low pressure, low temperature ammonia vapors, it enters a container known as absorber. It enters a container known as absorber. So I can say that this is the second part, absorber. So within this absorber, there is a water which is an absorbent. Ammonia vapors are easily soluble in water, and in this absorber, there is a formation of low pressure, strong ammonia solution. There is a formation of low pressure, strong ammonia solution. Now, this low pressure, strong ammonia solution, it is being taken and pumped to the generator with the help of a pump. With the help of a pump, it is being taken from the absorber and it is pumped towards the generator. Passing through what? Passing through heat exchanger. Passing through heat exchanger. So as it is being pumped, the refrigerant vapor, that is the strong ammonia solution, is pumped through this heat exchanger and it is sent to the generator. Here, when we use the pump, the pressure and temperature increases to form high pressure, high temperature strong ammonia solution as it enters the generator. This is the generator. High pressure, high temperature strong ammonia solution to enter the generator. Now within this generator, students, you can see we have used a heating coil. It is used for supplying the heat, where you can use combustion of fossil fuels, you can use solar energy or any other heating element to heat this heating coil in such a way that this strong ammonia solution, it is being heated to a higher temperature. And as you know, the boiling point of ammonia and water are different. The ammonia vapors get separated from the water, and these ammonia vapors they are collected here. You can see here in the form of dots, and these ammonia vapors, they next move strong high pressure, high temperature ammonia vapors. Now they next move towards the next device. We call it as the condenser. Move towards the next device. We call it as the condenser. This is the condenser. In the condenser, students, as this there is a air, as the ammonia vapors, high pressure, high temperature ammonia vapors, they pass through the condenser tubes. The tubes are exposed to the surrounding air, and the air passing through these condenser tubes, it extracts the heat. That is, the heat is ejected from the condenser tubes to the surrounding, and by the time the refrigerant comes out of this condenser, its temperature is being dropped due to condensation process, and there is a formation of high pressure, low temperature liquid ammonia. So by rejecting when the refrigerant rejects its heat to the surroundings by the surrounding air, then there is a condensation process, drop in temperature, due to which there is a formation of high pressure, low temperature liquid ammonia, and this high pressure, low temperature liquid ammonia now enters the next part, it enters the next part known as expansion wall, that is number 4. So in this expansion wall, already you know, it is especially used for reducing the pressure of the refrigerant as it passes through the expansion wall, and after it crosses the expansion wall, we have low pressure, low temperature liquid ammonia, that is the refrigerant, which again circulates to the evaporator for the next cycle. So if you observe here, students, carefully, these particular parts, that is the use of generator, the use of generator, absorber, pump, heat exchanger, they are all nothing but they are working as the same as that of an compressor, which we have seen in VCR system. So here the compressor is replaced by number 1 generator, absorber, and a pump. The purpose of heat exchanger is to see that we can use the heat rejected from the warm solution, that is warm weak solution, to supply the heat to the strong solution coming from the absorber. And how it is done? So if you observe here, students, carefully, in this generator, once the ammonia vapors move out of this generator container, then whatever you are seeing here, this solution, it is a weak ammonia solution which is having some amount of heat within it. We call it as warm weak solution. We call it as warm weak solution. This warm weak solution, it is taken back towards the absorber, passing through a device known as heat exchanger. So in this heat exchanger, this warm weak solution, it gives away its heat. See, it is giving away its heat, and on the other side of this heat exchanger, you can see here we are taking the strong ammonia solution from the absorber container, which is pumped with the help, which is pumped to the generator, passing through the heat exchanger. So you can see, so this pipe now the containing the strong ammonia solution, its temperature is less when compared to this warm solution. So this green color arrow mark, they are indicating regarding the hot temperature which is being rejected and it is absorbed by the fluid, by the strong ammonia solution passing through this network, that is the red colored structure. So therefore, what we can say that for every cycle, the amount of heat required, it is less when compared to the initial cycle. This is the purpose of using the heat exchanger. I hope these things are clear to you, students. Now, in this way, the entire cycle repeats from evaporator to absorber. As I said, once more I will show. The cycle repeats again from evaporator to absorber. Then from the absorber, the strong ammonia solution is pumped using a pump to the generator, passing through heat exchanger. So in the generator, the ammonia vapors are separated and it moves to the condenser where it is being condensed to the reduction in temperature, and to reduce the pressure, it is then further passed through the expansion wall where the pressure is being reduced. Okay. Now let us study regarding some of the comparisons or differences between VCR and VAR. So as I said, students, the comparison, it is made upon 10 factors for a VCR and VAR. The first factor is regarding the working method. So if you observe the working method for the VCR, the refrigerant vapor in the VCR, it is compressed to high pressure, whereas in the VAR cycle, it is heated and absorbed. It is first absorbed in the absorber and then heated in the generator, where the vapors are sent to the condenser. Then the type of energy supplied for the VCR, students, the type of energy supplied for the VCR, the energy supplied is mechanical energy, whereas for the VAR, you can use heat energy, and this heat energy is used by the combustion of fossil fuels. You can go for solar energy, or you can use even any of the heating elements to develop the heat energy. The third factor regarding the work or mechanical energy supplied for VCR students, as we know that we are using a compressor, the refrigerant vapor has to be compressed to a higher pressure, which means the work or mechanical energy supplied is comparatively more for the vapor compression refrigerator. Whereas on the other side, we need to run only a small device known as a pump. So therefore, here we need less energy when compared to vapor compression refrigeration. Then regarding coefficient of performance, in the VCR, even though our coefficient of performance is very high, but when we go for reducing the loads or at part loads, this COP is almost the higher itself. So if the load is at part load condition, then also COP is higher. But when you come for the vapor absorption refrigeration, our COP is smaller. And again, when it is used at even some less or even some part loads also. Then coming on to capacity students. In the VCR, one single compressor which is used, that single compressor unit, it can produce up to 1000 tons of refrigeration. Whereas in a VAR, we don't have a compressor, but the absorption system which is there, it is designed in such a fashion that it can work again above 1000 ton of refrigeration also. Then regarding noise, as we know that a compressor which is used in a vapor compression refrigerant system, it is consisting of moving parts in the compressor. The formation of noise is very much, that is more noise. Whereas in the VAR, there is a use of compressor is not there. So therefore, you can say that there is absence of noise or very, very less noise. Then refrigerant students. For the VCR, the refrigerant used is Freon 12, whereas for the vapor absorption refrigerator, ammonia is used as refrigerant. Leakage. As I said, in the VCR, we are using the compressor, which is consisting of moving parts, and here the vapor is compressed to high pressure, which means the chances of leakage in this vapor compression refrigerator is more when compared to vapor absorption refrigeration. So in vapor absorption refrigeration, there is no such type of leakage. Then coming on to the maintenance point. When we are using a compressor, as I said, there are a lot of moving parts inside the compressor. Then the vapor is compressed to high pressure, more amount of energy is required. So here the maintenance chances are very high. So you can say that there is more maintenance because of the presence of compressor. Whereas in the VAR, we don't have compressor, but there will be some maintenance. It is relatively very, very less when compared to vapor compression refrigeration. Then regarding the operating cost, students, the operating cost for the VCR, it is little bit costly in nature because, as I said, the designing of compressor itself is a big challenge, and it is consisting of moving parts. You need to lubricate the compressor continuously, and you have to check whether it is working properly or not. So if there is a damage in the compressor, then the entire system fails. So therefore, you can say that it is a much costlier process. Comparatively here, we don't have compressor, and it is a cheaper process. So this vapor compression refrigeration we can use domestically at our homes, whereas vapor absorption refrigeration we can use in offices, banks, you can use in the theaters, hospitals, everywhere where there is a mass production. Sometimes you can use even in the recreational vehicles also. So this is about the comparison of the vapor compression refrigeration and vapor absorption refrigeration. So today we will stop here, students. In the next session, we'll be discussing regarding properties of a good refrigerant, as well as a discussion on different types of refrigerants. Thank you, students.